All right, last section here that we're going to talk about are physical characteristics of the sun, the earth, and our moon, and the relationship between those three. We know our sun is actually just a medium sized or average sized star. It is giving off heat and light that sustain life here on Earth. We know it's mostly composed of hydrogen and helium. And what we see on the surface of the sun are fusion and fission reactions. Basically, it's just a huge nuclear reaction in the center of our solar system. And it's those reactions that are giving off so much energy. So we have to have the light energy in order to carry out photosynthesis for plants. Plants give us our oxygen. Without plants, things like herbivores wouldn't have any food to eat. So ultimately, all life on Earth would die. We also know that the sun is sustaining our temperatures here on Earth, giving us warmth and that energy that is going to keep us from going into an ice age. So we know that 1,000,000 Earths could fit within the sun. And because it's just a large glowing ball of gas, it actually can rotate at different times between the equator or the poles. Let's talk about Earth a little bit. We know it is a rocky planet. It is the third planet from the sun. 70 to 75% of the surface is covered with liquid water. Because of that, it is able to sustain life. As of March 1st, 2021, it is the only planet in our solar system that life exists on. We know that scientists and astronomers are looking elsewhere to see if they can find signs of life. We know we have a protective atmosphere, and that atmosphere helps us to contain our oxygen. It also helps us to contain our water that exists in the water cycle. So that both of those support life. But another important thing is it is preventing the radiation from the sun from bombarding us every single day. So without our atmosphere, again, life would cease to exist here on Earth. We know that it takes us about 24 hours to spin around one time on our axis. And we know that it takes Earth about 365.25 days to make one trip around the sun. That trip we call a revolution or an orbit. We know that 0.25 is critically important. If we were not to account for that in our calendar would be completely off. We would have seasons all mixed up. So to account for that 0.25 or that quarter of a day every year, every 4 years we add in a new day to the calendar, and that's February 29th. That's what we call a leap year. And it's very important that we do that. That way we can keep our calendar and our seasons all aligned as best as possible. It's not important that you know the layers of the Earth. I left this here in case you're interested in looking at that. Let's talk about the moon. We know the moon is a natural satellite of Earth. Our gravity is holding the moon in its orbit. We know that about 50 moons could fit inside the Earth, and it only has 1/6 of our gravity. So less gravity than Earth, but I wouldn't just float away completely. We know that the moon is considered to have little or no atmosphere, and because of that, a lot of craters are able to strike the surface of the moon. Yes, some meteors can absolutely strike the surface of Earth, but they have to start very, very large because most of them burn up in our atmosphere before they ever strike the surface. We know we see temperature extremes on the surface of the moon, whether you're facing the sun or you're on the dark side of the moon, because it has little to no atmosphere. The moon rotates extremely slowly. It takes about 27 days for it to spin around on its axis, which is about the same time it takes for it to make one loop around Earth. So because its rotation and its revolution are about the same time, we only see one side of the moon. So I always joke around with my class to say that maybe Transformers, the movie Dark Side of the Moon, maybe they were right. Maybe the Decepticons actually do live on the dark side of the moon because we cannot see that from Earth. We're just always looking at the same side. Okay? So let's go on here to the Sun, Earth, Moon system. So here's where we're talking about the relationship between these three. We know the sun has the largest mass. It's 99% of the mass of our entire solar system, so it's huge. And its gravity is holding us along with the other 7 planets in our orbit. And like I said, our gravity is holding the moon in its orbit. So we see here these loops, and these loops are what we call an orbit or a revolution. So 365.25 for us to go all the way around the sun one time. That's how many days, or you could say it's a year. And then we know that the moon takes about 27 days to get around us. So one thing I always say is, how many trips around the moon have you been? I'm sorry, how many trips around the sun have you been? I'm 40 years old. I've made 40 trips around the sun. If you're 11, you've made 11 trips around the sun, right? So every year you make one trip around the sun. Just to break these two terms down, rotation, we know that's where Earth is spinning on its axis counterclockwise. And this axis is actually tilted 23.5 degrees. That's going to be really important when we start to talk about the seasons. But then this revolution is also the orbit. Okay? Important to know the planets. Unfortunately, Pluto got kicked out of the club. It's no longer a planet. He's considered a dwarf planet. So we have the 8, okay? And these are listed in order from the sun. And the little acronym we use is my very educated mother just served us nachos. And so that's something helpful to just jot down whenever you're taking your test. That way you can make sure you keep the planets in the correct order. Now, later on this week, we're going to talk about high tide and low tide. This has to do with the moon and the sun's gravity. So I'm not going to spend a lot of time here talking about it because we'll talk about it later on. But it's very interesting that even though the moon has a smaller amount of gravity than Earth, it's still close enough to us and it still has enough gravity to actually start to pull on the water, which is moving on Earth. Okay, so it can affect our tides. Seasons. Let's look at that a little bit. So we've drawn a diagram that talks about Earth's revolution or orbit around the sun, but it also has to do with the tilt of the Earth. We know that we can draw the equator. Okay, so I'm going to draw it right here on this one. And we know we have a northern hemisphere and a southern hemisphere. We live in the north. We know when the northern hemisphere is tilted towards the sun, this is when we're going to be our hottest. So this will be our season of summer. When the Earth orbits around and the sun is kind of to the side, this is when we would have fall, right? Because we have summer, what comes next is fall. Then we move over here in our orbit or our revolution. Here we see the northern hemisphere is tilted away, and this is when we would have winter. However, my friend that lives in Australia, they're going to be having summer. So they're the opposite of us. So after winter, then we experience spring. And so we are currently moving into this position. March 21st will be the first day of spring. And so right now, this is where Earth is in the orbit. We are moving around.
Students and teachers, it is that time, 3:20 on the wall clock. It is time to go home, students. I hope you had a great Monday. Reminder, tomorrow, if you did not turn in your cookie dough, it is due tomorrow, last day. So make sure you turn it in. Students, have a great day. Teachers, remember these bus riders.
So we are moving in from this point in winter to March 21st. We will officially start spring. And so we'll be here where the sun is more to the side of the Earth. So we have nice mild temperatures and mild weather. We're going to talk more about the moon phases after spring break. We'll talk a little bit about these on Friday so you get a better understanding of why we only see certain portions of the moon during certain times of the month, and then being able to predict what phase the moon is going to be in. One really, really important concept is the day-night cycle. When you think day-night, I want you to think rotation. What I told my students, you could have a little play on this word, and the play would be rodation. So if we just kind of intentionally misspell this word to say rodation, then that helps us to remember it's the rotation that's giving us our day and our night. So what we see is the Earth is tilted, but we see half of it's going to be dark. That's the half that is away from the sun, while the other half that's facing towards the sun is going to be experiencing day. Okay. So here's another example. You got to remember the sun rises in the east. What I told my kids is if you look at that word rise, it ends with an E. So you can always remember rise in the east. That's an important way to remember it. And it's going to set in the west. Okay. So it's actually the Earth spinning around on its axis that makes the sun appear to move. It's not moving, right? The sun is just in the center of our solar system, just rotating. However, because Earth is spinning, it's going to make the stars, including the sun, appear to move across our sky. So in relation to the sun rising and setting, you need to have an understanding of shadows, right? Shadows can actually grow and shrink We know shadows are going to be longest early in the morning or late in the afternoon. And the shortest shadow is going to be right here about 12 o'clock or noon when the sun is directly overhead. Okay. And I can promise you that there are going to be questions on your test that are going to give you examples of shadows, and they're going to ask you, well, what time of day would it be? Right? If you see that the sun is here in the east, you know it's morning, and the shadow is cast in the opposite direction. All right. I left these slides here about comets, asteroids, and meteoroids just to kind of strike your interest. A lot of people always wonder what these are. And then, of course, we are located in the Milky Way galaxy. Lots and lots of stars out there. And we're in just one little tiny arm of this huge galaxy. So, in the whole scheme of things, we are super small. So, if you have any questions specifically about rotation, revolution, or the relationship of the sun, moon, and earth, please make sure you check with your teachers.